Hi everyone. Today we are going to start with one of the most important application layer protocol, that is HTTP, standing for Hypertext Transfer Protocol. In a typical client server model, this protocol can be used to send data between clients and servers. So if you're trying to fill a form on the internet, or if you're trying to log in on the internet, or even if you're trying to browse on the internet, in most likelihood you are going to use this application layer protocol. Now, most of the HTTP versions that we're going to go through primarily works on TCP connections on the transport layer. If you go through the evolutions of HTTP protocol, you would see that it expands through decades, with the very first version introduced in 1991. Now, each of these versions brought in improvements and enhancements on top of their predecessor version. And although most of these versions are obsolete and not in use today, but it is very important to go through all of these versions and the nuances and improvements that each one of them brought. And that will help us understand the evaluation process of the application layer protocols. So, beside HTTP or gRPC or any other application layer protocols that can be used during system designs, right? So, let's get started with the very first HTTP version that we had, that was HTTP 0.9. HTTP 0.9 was the first version to be released, and it only supported one method, that was the GET method. The clients could not send the data to the servers. The clients would only request for a data and the servers would send the data. And there was no HTTP headers or metadatas that were allowed. So no content type or content length was allowed on HTTP 0.9. Only HTML text was allowed to be sent as raw bytes as a response from the servers, and no other file types were supported. So images, CSS, PDF can't be sent from the servers to the clients. And the servers were not able to send the HTTP status code also as part of the response. So whether it was a success or a error scenario could not be sent from the servers. So let's understand this with the help of an example, how it worked. Let's say we have a client and a server, and the client would request for a resource. So let's say it fired a get resource with a path to the resource. Let's say it was present at index.html. Now the servers would respond back. So as the request was made, a TCP channel was opened, a TCP connection was opened, and on this TCP connection, a request was sent. So for every different request, a separate TCP connection was opened. So once the request was reached, the servers would respond back uh, with the contents of this file, that is index.html, as raw bytes. Okay. Now this raw bytes was neither encrypted nor encoded. Just an ASCII raw byte was sent back to the clients, and the clients would read these raw bytes and they would basically unmarshal that data, raw bytes, as plain text HTML data. Okay. Now, once the servers were done sending all the raw bytes, it would snap the connection. It would snap and break the TCP connection, and that is how the clients would know that all the response has been sent by the server. So, because your content length was not mentioned on the response, the clients did not have any idea as to how much more data is pending or how much more data has come, and it would keep on listening on to the request until the connection was alive. Okay, and as soon as the connection was snapped, the clients would assume that all the data has been sent now. So there was no error handling also, because your status code was not present, so it would not know whether there's a internal server error has happened, or if this is a file not found for which I have requested. So there was no error handling. Also, the clients would not be able to differentiate when the connection would have dropped. It was not able to differentiate whether this drop is due to a network congestion or a network error, or whether this drop has happened because the server has done sending the data. Okay. So no proper error handling was there. Now, because the content type was missing, right? So server was only allowed to send raw bytes. Now this raw bytes could be anything. It could be HTML data, it could be data from PDF, it could be image.png, any file format it could have sent. But the problem was, since the clients were not aware that this particular raw byte is coming for what content type, whether it's an image or whether it's a HTML file, they would always assume it's an HTML file. by default. Okay, and since no content type was present, it would always read the raw bytes as HTML, and if any other file was to be sent, it would assume that those raw bytes are corrupted because it could not be interpreted as an HTML file. Okay, so the servers were bound to only send the HTML data because the content type was missing. So these were the issues that we had with HTTP 0.9. No metadatas were allowed. So as a result, only HTML bytes were sent. No status code was there, and no error handling was present. And only one method, that is the get method, was allowed. So the clients could not send the payloads to the servers. And for every request, there was a separate TCP connection that need to be opened. So there was resource exhaustion also. So despite having all these issues with HTTP 0.9, yet it proved very pivotal for the internet, because it was through HTTP 0.9 it was proved that internet could exist in the form that we see today. Okay. So in the next video, we'll cover HTTP 1.0, how it improved, brought in enhancements and improvements on top of HTTP 0.9. So that's it for today. Thank you.